Hi guys, I'm going to be going over number 4 on the 2021 exam. It says, let f be a continuous function defined on the closed interval -4 to 6. The graph of f consisting of 4 line segments, 1, 2, 3, 4, is shown above. Let g be this function. Well, as soon as I see a graph and it says that it's the graph of f, but then they give me a function for g, just like we practiced this past week, I'm going to immediately take the derivative of g, so g prime of x. Well, if I take the derivative of this integral, it's my fundamental theorem of calculus. They would cross off, and I would sub x in. So g prime of x is equal to f of x. So that means that this is the graph of f and the graph of g prime of x. So I'm going to keep that in mind as I answer the questions. Part A. On what open intervals, so that means parentheses, is the graph of g concave up? So I want to know when g is concave up. Well, I'm looking at g prime. So g would be concave up where g prime is increasing. And so my open intervals would be from -4 to -2 and from 2 to 6. And my reasoning would be because g prime of x, and I would even go as far as to state equals f of x, is increasing. Now, because I had already stated it right here, I don't necessarily need to state it again right here, but I do this just to be safe. You'd likely get away with just putting g prime here. Okay, part B says, let p be the function defined by g of x times f of x. Find p prime of 3. So I'm going to do part B up here so that I can keep this graph kind of large for you all to see. So it says that p of x is equal to g of x times f of x, and we are asked to find the derivative at 3. Well, before I can find the derivative at 3, I need to just find the derivative. This is going to be a product rule, first and second. Here we go. Product rule says first, just copy it over, times the derivative of the second, f prime of x, plus the second term, f of x, times the derivative of the first, g prime of x. And I'm looking for p prime of 3. So p prime of 3, make sure you're using good notation, is g of 3 times f prime of 3 plus f of 3 times g prime of 3. And let's try to evaluate each piece of this. So the first piece, which says g of 3. Well, I know that this is g of x. So g of 3 would simply be the integral from 0 to 3 of f of t dt. I'll evaluate that in a moment. Times f prime of 3. Well, this is the graph of f. So if I'm looking for f prime, I'm looking for the derivative at 3, or the slope at 3. This is linear, and my slope is just simply rise over run, which is just 1, plus. Next up is f of 3. Well, this is the graph of f. So f of 3, I'm down here at -3. And last up, g prime of 3. This is the graph of g prime. So g prime of 3, I'm down here again at -3. All right, to complete this part, I'm going to need to evaluate this integral. And an integral is going to measure the area under the curve from 0 to 3. So if I'm trying to find from 0 to 3, I can say from 0 to 1 is a triangle right here. I know that the area of a triangle is 1/2 base times height. So this area would be 2. And then I need to go all the way to 3. So I'll first go to 2, which is 1/2 base times height. It's under the axis, so it's negative. So this has an area of -2. And then I need to go to 3. And this is a trapezoid. And the trapezoid formula is 1/2 my height here, which is just 1, times base 1, which is this, 4, plus base 2, which is 3. So this is 7/2. I'm going to call it -7/2 because it's under the axis. So if I'm trying to find the area all the way from 0 to 3, the 2 and the -2 would cross each other out, and I'd just be left with -7/2 times 1 plus -3 times -3, so plus 9. And I wouldn't simplify, I'd leave it just like that, and that would be my answer to part B. Okay. Part C asks me to find a limit. Now, not always, but typically if we are in a free response and they give you a limit, typically it's a L'Hopital. So I kind of have that in the back of my head that this is probably going to be a L'Hopital. But I'm going to attempt to plug in first. I'm going to imagine plugging 2 in, and if I just substitute 2 into the denominator, I get 0. And if I substitute 2 into the numerator, g of 2, this is g, and g of 2 would be the integral from 0 to 2. Well, the integral from 0 to 2 is 0, because 2 minus 2, just these areas. So using good notation, and I'm going to fit this in here, I'm going to put a little arrow, and I'm going to say lim as x approaches 2 of g of x equals 0. And then I'm also going to write the limit of the denominator. Limit as x approaches 2 of x squared minus 2x equals 0. So I'm showing that they both equal 0. And then I'm going to use L'Hopital's rule. L'Hopital's rule, I recopy the word limit. And I take the derivative of the numerator and the derivative of the denominator separately and write them here. So the derivative of the numerator is g prime of x. The derivative of the denominator is 2x minus 2. And then I'm going to substitute in. If I substitute 0 into the denominator, I have -2. And if I substitute 0 in here, this is g prime of 0. Look here, this is the graph of g prime of x. So g prime of 0, we're up here at 4. You don't have to simplify that. In fact, I'd probably encourage you not to, but 4 divided by -2 is -2. So then I'm going to do last part, part D. Part D says, find the average rate of change of G. So the average rate of change, that's a formula. That's f of b minus f of a over b minus a. But what we're going to use is g instead of f of b. We're going to say g of 2 minus g of -4 over 2 minus -4. That's going to be my average rate of change. My denominator is 6. My numerator, if I'm looking for g of 2, remember this is g of x. So g of 2, I would go in and I would substitute 2 in. It would be the integral from 0 to 2 of f of t dt minus g of -4. I'm going to substitute -4 in here. So the integral from 0 to -4 of f of t dt. Now, when you're evaluating these integrals, it's going to be the area underneath the curve. So for my first one, I'm going to zoom out here. For this first piece, the area under the curve from 0 up to 2. I have a triangle up top that's 2 and a triangle on the bottom that's -2. So those areas cancel each other out, and I'm going to say 0. Now, one thing I'm also noticing is that when I look at this next definite integral, the smaller number is on the top. So we're allowed to switch places as long as we switch the sign. So I can turn this into plus the integral from -4 to 0. I just kind of like it better that way. And if I keep going here, I need to figure out what the area under the curve from -4 to 0 is. So I'm going to come back up here. And from -4 to 0, I haven't found this area yet. And so I need to break this into shapes that I know how to find the area of. This is a triangle. Area is 1/2 base times height. And that is going to be just 6. This piece right here is a trapezoid. The formula for this for any trapezoid is 1/2 times your height, which is 2 in this case, times base 1, which takes me up to 6, plus base 2, which takes me up to 4, and I get 10 right here. So if I'm trying to evaluate the integral from -4 to 0, it would be these areas. 6 plus 10, and I get 16. And again, I wouldn't simplify because we never want to simplify. And I'm actually not quite done with part D. Part D says, find the average rate of change. We did that. But then it says, does the mean value theorem guarantee a value C where G prime of C is equal to this average rate of change? Well, the mean value theorem only works if my function is continuous and differentiable. So I want to know, is G continuous and differentiable? That's kind of what I'm thinking in my head. And that would mean that the mean value theorem would work. So I'm going to go up and look at my graph. This is the graph of G prime. Well, since this graph of G prime is defined everywhere, there's no holes, no asymptotes, no jumps. Since G prime is defined everywhere, I can make a statement that says G of X is differentiable. And I know that because the derivative was defined everywhere. And therefore, it must have been continuous. So because of that, I can say, yes, mean value theorem guarantees C. I could be a little more specific on -4 to 2. Okay. So there is problem number 4. In terms of grading this, they haven't released a grading scoring guideline yet, so I would just be making guesses as we go through this, but you should grade your own, and I would guess that part A was worth 2 points. I would guess that part A, you got 1 point for your intervals and 1 point for your explanation. I would guess that part B is worth 3 points. It's just a guess. I would guess that you would get 1 point for correctly writing down your product rule. I would guess you would get 1 point for substituting 3 in, and 1 point for coming up with your final answer. I would guess that part C was worth 2 points. 1 point for explicitly stating that each of these limits is 0, and 1 point for coming up with your answer. And then part D, I would guess, would be worth 2 points. 1 point would be for finding your average rate of change, and 1 point would be for stating that the mean value theorem would work.